Imagine walking through a foreign city and seeing a menu written in a language you don't speak. You don't reach for your phone or tap a screen, you just look at it, and a voice in your ear instantly translates the daily specials. This isn't science fiction. It's the core of Apple's massive engineering pivot. They are moving away from the isolated world of immersive VR and towards something far more ambitious: ambient intelligence. For years, the industry thought the end game was a digital world we stepped into. But Apple's latest internal moves suggest they've realized the real prize is the physical world we already live in, enhanced by AI that never gets in the way.
The Vision Pro was a technical marvel, but let's be honest, it's heavy, it's expensive, and it cuts you off from the people around you. Apple's engineers are now reportedly focusing on hardware that does the exact opposite. Leaks have surfaced regarding 3 distinct projects: AI-powered glasses, a wearable AI pendant, and, most surprisingly, AirPods equipped with low-resolution infrared cameras. They want to give Siri eyes. This is a fundamental shift in philosophy. Instead of bringing you to the computer, Apple is bringing the computer to your senses. And the engineering required to make this work is genuinely mind-blowing.
To make this happen, Apple has to solve a problem that has plagued wearables for a decade. How do you interpret the world without a screen to show the user what you're seeing? The answer lies in a massive upgrade to Siri. We're talking about a transition from a voice-activated timer to a proactive agent that understands context, space, and physical objects in real time. But to do that, Siri needs a constant stream of visual data, and that's where the camera AirPods come in. It sounds wild, but the technical logic behind it is actually quite elegant. Think about where your AirPods sit. They have a clear, unobstructed view of the world around you. By adding low-power cameras, Apple can create a constant spatial awareness loop that runs in the background. This isn't about taking photos for Instagram. It's about visual odometry, the ability for a device to determine its position and orientation by analyzing the movement of images from its cameras. If Apple can pull this off, they won't just have a better assistant. They'll have a device that knows you're looking for your keys before you even realize you've lost them. But the road to this future is paved with some massive engineering hurdles.
We've seen the vision, but how do you actually cram a computer vision pipeline into a device the size of a grape? The hardware constraints are unlike anything Apple has ever faced. In the next module, we're going to dive deep into the silicon eye, the actual code and processing steps required for Siri to see. It's a journey from raw pixels to meaningful action, and it's happening faster than you think. But before we get there, we have to ask, is the world ready for a pair of headphones that are always watching? The answer might lie in Apple's obsession with on-device processing.
When you look at a chair, your brain doesn't see a collection of brown pixels. It sees a chair, an object with a specific function. For an AI, that leap from pixels to meaning is a Herculean task. Apple's computer vision pipeline starts with the Image Signal Processor, or ISP. In these new wearables, the ISP has to be incredibly efficient, cleaning up grainy, low-light footage from tiny sensors in real time. But the ISP is just the beginning. The real magic happens in the neural engine, where a multimodal large language model, or MLLM, processes that image alongside your voice and location data. To understand the world, Siri uses a technique called semantic segmentation. It's the process of labeling every single pixel in a frame so the AI knows where the sidewalk ends and the street begins. On a device like the Vision Pro, you have massive power to do this. But on a pair of glasses or AirPods, Apple has to use sparse processing. Instead of analyzing every pixel, it only looks at the most important features. This is where Apple's H1 and H2 chips and their successors come into play. They're being redesigned to handle these vision tasks with millisecond latency. If the AI is slow, the experience is broken.
But what happens when you're indoors? GPS doesn't work well there. Apple's solution is Visual SLAM, simultaneous localization and mapping. The device builds a 3D map of the room as you walk through it. By tracking anchor points, like the corner of a table or a picture frame, the device knows exactly where it is in space. This allows Siri to give you directions like, your charger is on the nightstand to your left. This level of spatial awareness is the holy grail of wearables. It turns the entire world into a searchable database. But it also creates a massive data problem. How do you process all that video without burning a hole in the user's pocket?
Critics argue that always-on cameras are a privacy nightmare, and they're right. If this data went to the cloud, it would be the most invasive surveillance tool ever created.
Apple's counterargument is on-device intelligence. They claim the raw video never leaves the device. Instead, the chip processes the video, extracts the meaning, like there is a dog, and then deletes the frames immediately. This requires a massive amount of neural engine horsepower. It's why Apple is reportedly testing prototypes with a wired connection to an iPhone, using the phone as the brain while the glasses act as the eyes.
But a wire is a deal breaker for the mass market. No one wants a cable hanging from their ear. This leads us to the ultimate engineering trade-off: power versus performance. Apple is currently stuck between a smart device that is too bulky and a sleek device that is too dumb. How they bridge this gap will define the next decade of consumer tech. In our final module, we're going to look at the leaked prototypes that show exactly how Apple plans to win this war. From thermal management to the pendant form factor, the solution is closer than you think.
The biggest enemy of ambient intelligence isn't the software, it's heat. When you process high-resolution video on a device sitting against your skin, things get hot, fast. Apple's engineers are reportedly experimenting with liquid metal alloys and advanced carbon fiber frames to dissipate heat without adding weight. They need the glasses to feel like, well, glasses. But even with exotic materials, the battery remains the bottleneck. A pair of glasses has almost no room for a traditional lithium-ion cell. This is why the AI Pendant is such a clever alternative.